What I would like to share in the next 10-15 minutes is what we are doing in the robotics space and along with Velodyne. Um, so our charter, what we are trying to do in robotics is to bring artificial intelligence to the edge, and it is fundamentally based on our CUDA architecture, which is using GPUs for computer vision and artificial intelligence, neural network inference, and so on. And within that, we've got basically 4 different flavors of the edge computing solutions. One is called Jetson, which is the base computing platform. Pretty much can be applied for any type of application. And there are 3 more specialized applications. One is called Drive, which is, I'll spend a little more time on that, on which we are actually collaborating pretty closely with Velodyne. And then we have got Clara, which is our medical applications. And the last one, which I will deep dive into, is Isaac Robotics. Isaac is our robotics platform for indoor robots, collaborative robots, and stuff like that. And here again, we are working closely with Velodyne. So I'll start with NVIDIA Drive. Drive is our autonomous driving platform for autonomous cars, and this is an area where we are pretty closely collaborating with Velodyne. And one of it's a pretty end-to-end platform. It starts with the computer in the car, all the way to simulation platform, to build out and test, validate an autonomous car. And one of the important places here is the collection of data collection and training of neural networks, and we deeply engage with Velodyne on that front. So that's one. The other one is Isaac Robotics, which is what I'm going to spend a little more time, that's what I'm responsible for, is Isaac Robotics is fundamentally aimed at two types of robots. One is the indoor navigation robots, and the other one is the manipulation robots. And here we use Velodyne a lot in terms of for both neural network training as well as for navigation of robots. And it's one of the key pieces of Isaac software is our Isaac engine, which is a core engine on which the whole application and the key capabilities of the robot work. And so what you see is a visualization tool, a computational graph-based development, and also a pretty advanced build system to use different components. And the second key piece is of Isaac Robotics is the GEMS, or Isaac capabilities. And here's where we use a lot of perception and navigation, path planning, algorithms, which are deeply tied with Velodyne. And a bunch of capabilities that we package along with this SDK includes things for perception, path planning, collision avoidance, pose estimation of objects, and stuff like that. Right, so and also human-robot interaction, like audio, speech detection, gesture recognition, and things like that. So these are all packaged along with it. And the third piece of our Isaac SDK is our reference designs. There are 2 reference designs. One is for indoor robots called Carter, where you might prominently see the puck LiDAR from Velodyne as a core sensing capability of that robot. And that's meant for really indoor logistics, etc. So this is a core reference design for that. And the second one is Kaya, which is our kind of getting started robot based on a holonomic wheelbase. And this is a robot that people can get started with. And of course, these robots could be adapted for different applications and use cases. And the last piece is simulation. So what we do is we take Isaac, part of Isaac SDK, we use simulation for both training the neural networks that are used for perception, as well as testing and validating the robots before they are actually deployed in a real environment. So here again, we use Velodyne LiDAR simulation to test out the navigation capabilities of the virtual robots before they actually go into the real world. So lastly, kind of concluding, we are bringing a lot of things to CES 2020. One of them is Isaac SDK, and one of the key partners is Velodyne. There are a bunch of other things happening at CES. You might want to check it out. So it's a quick and short presentation, but I'd love to take any questions if you guys have.